All right, good afternoon, everybody. My name is Emily Adams. I work at Nutrien located in Aurora, North Carolina. My colleague Bill Wilkinson from Datamine in Denver, Colorado are very excited to present to you a case study today, which is going to understand and identify unstable materials for dragline bench designs. So to begin, I wanted to give you a little bit of background of who we are at Nutrien and what we do. We are a phosphate mine. We are located on the beautiful eastern North Carolina coast in Aurora, North Carolina. We use truck excavators and draglines for our mining process, and we mine about 4.74 million tons of phosphate a year. We are one of the largest integrated phosphate mining and chemical plants in the world. To the right-hand side of your screen are a couple photos from our operations, and it's a really awesome place to work. Moving on, just to give a brief overview of the geology at Nutrien Aurora. We are on the coast, as mentioned, so all of our materials are consolidated to unconsolidated sediments, which are quaternary to tertiary in age. These sediments were deposited as a result of lacustrine, aeolian, marine, fluvial environments. If you look to the left-hand side of your screen here, you can see what we have as our overburden material and pre-stripping material. This is those materials that I just mentioned. Down here at the base of this picture is where our dragline bench and where our operating equipment sits at. We do only mine our phosphate ore zone, which was a direct result of recession of the seacoast of the Aurora area about 15 million years ago. This ore zone ranges from 30 to 40 feet thick and is rich in phosphatic sands, quartz, pebbles, clays, and my favorite, we have some awesome fossils out here at the site. So the overlying material is 90 to 140 feet thick and are sand, silts, and clays. So diving in a little bit deeper to the geology and what encompasses the role of the geologist at the site. So I work to gather new data-built geologic models and produce short, medium, and long-range mine plans. In doing so, I use the Datamine MineScape software. These plans will depict structure, quality. Additionally, we identify zones that are unstable material that can result in an unsuitable bench for the surface of the dragline. This is a really important step in the process because these zones are critical to identify to effectively reposition the dragline around these zones during its work cycle. So to the right-hand side of the screen is an example of the geologic model built in the Datamine MineScape software that we use to make plans and decisions off of. Moving a little bit forward and diving in a little bit deeper to the structure modeling in the MineScape software. It consists of 15 contiguous lithologic intervals, and we use these intervals to plan and develop ideas for where we're going to position the dragline. We built this model off of drill hole data, topography, and we use the Datamine MineScape strat model function. On our site, the ore body is the only zone that exists continuously, and the remaining intervals are very widely in thickness, and some of them only just exist in a few locations around the site or just a few drill holes. They can be anywhere from pinch, 0 feet, upwards to 50 feet thickness, which just adds more complexity and dimension to the geologic model. Over here on the left-hand side of the screen, if you look at the pink CSCH interval, you can see it did start as a very thick unit and it ended up becoming pinched as we progressed through the area. In addition to structure modeling, we also do quality modeling on the site, but we just limit this to our phosphate ore zone. This quality data is composited from an Excel spreadsheet and they are imported into the model using a inverse distance squared function. To the right-hand side of the screen is an example of one of our quality maps that we use for planning purposes. All right, so now that we have a brief overview of what we are, who we do in our geology, I'm going to dive a little bit more into how we identify the unstable bench material in order to make plans for the draglines. So on the site, we've identified 3 lithologic intervals that are not suitable for supporting the weight of a dragline. These have been identified because they're either sand with high hydraulic conductivity and transmissivity. A lot of water would come out of these zones. Or we might have cobblestone units with uneven textures, making it not safe or suitable for a dragline to stand on. And last but not least, we do have some clay units that have high plasticity that make equipment very difficult to move and walk on. So we want to avoid these intervals as much as possible when determining my plans and an appropriate bench to sit the dragline onto mine. So in order to do so, we use MineScape strat model interrogation tools and visualization tools to determine if these materials are going to intersect the designed dragline bench and where that intersection would occur. To the right-hand side of the screen, this is a drill hole lithology function from the DataMine software. And if you look, the green unit at the base is our ore zone. This is just used for planning purposes and viewing purposes and understanding the model. So in order to identify these zones, we have to determine an appropriate bench for the dragline. For our site and for the purposes of modeling, we use a -20 elevation for the bench. And the geologic model was interrogated to determine if these unsuitable intervals will intersect this elevation. To begin, we contour the unsuitable materials of the roof at a -20 elevation to determine if these intervals are present and if they intersect the dragline bench at this elevation. Additionally, we do use some complex surface expressions which are imported into MineScape software to evaluate multiple materials and if they're going to be evaluated or intersect the bench. So if you look to the left-hand side of the screen, this is a more complex surface expression. This helps us determine if it does intersect, if any of these units will be intersected by our bench. So this gets imported into the MineScape software to help us get a better understanding of where those zones lie. Additionally, we do contour the interval thickness above and below that -20 bench to give us a more visual representation around the bench plane. If you look to the right-hand side of your screen, this is a MineScape strat model visualization tool, which helps us understand where these unsuitable materials are. For example, this is a thickness above where that material exists, so it just helps in the planning process and locating those hotspots that we want to avoid. Overall, based on this information, the mine geologist, myself, mine planning engineer, and mine planning staff determine a bench level from which the dragline can safely operate. Overall, in summary, these unstable overburden above the phosphate ore definitely presents a hazard on the site for just employee safety, dragline equipment, and just production efficiency. Therefore, it's really important for us to identify these materials. It's just critical for us to ensure designed and constructed benches will not intersect material that will result in an unstable bench. Developing an accurate geologic model that captures this overall lithology, geology, and ore zones is just key in identifying unstable material, which can overall just impact our mining operations. Using a stratigraphic geologic model since this MineScape software is necessary to model the complexities of using these different functions and looking at the multiple contiguous intervals that vary in thickness in existence. Overall, MineScape's made it really easy for my job to help identify these zones and just make it a safe working operation overall at Nutrien Aurora. Really appreciate your time today, and we welcome any questions in the chat. Thank you.